Hi everyone, Assalamualaikum. In this video, we are going to continue with evaluating limits using multiplying by the conjugate. Now we look at example 2, limits involving radicals. Find limit x approaches -1 x plus 1 over square root of x plus 2 minus 1. Okay, or radical x plus 2 minus 1. Let's say using direct substitution from the given question, when we use direct substitution, we just plugging -1 into variable x here. And after we replace the value of x, so we get -1 plus 1 over square root of -1 plus 2 minus 1. Okay. Then we simplify. We have -1 plus 1 over 2 minus 1 equals to 1. And square root of 1 equals to 1 minus 1. Okay. So we get 0 over 0, which is error or indeterminate. So means that in this case, we cannot use direct substitution to evaluate this limit. Alright? Alright, the solution should be like this. From the given question, we have denominator with radical function. Right? So means that we need to multiplying by the conjugate of denominator. Okay. So the conjugate of denominator, which is third x plus 2 minus 1 equals to third x plus 2 plus 1. We just change the sign outside radical symbol because the term inside radical symbol is considered one term. Okay. Never change the sign inside radical symbol. Alright. So this is the conjugate of this function. Alright. Or this radical. Okay. So when we multiply, we need to multiply top and bottom by the conjugate. Okay. Since the top and bottom are the same, that means this fraction is equals to 1. And when we multiply by 1, it will not change this original value. Right? So that's why we need to multiplying the top and the bottom with the same conjugate. Okay? And after we multiply fraction by fraction, so means that we need to multiply numerator and numerator, and we multiply denominator and denominator like this. Right? From here, we can see that numerator now not conjugate for each other. Okay. So, no need to expand. Okay. And from denominator, this is conjugate each other. Okay. So, to simplify the denominator, we can use a plus b times a minus b equals to a squared minus b squared if we have multiplication of the conjugate. Right? Right, so from here, we have limit x approaches -1. We still have the same numerator. And for denominator, we can use this formula. Okay, our a equals to third x plus 2 and b equals to 1. So from this formula, we can write third x plus 2 bracket squared, and then in between is minus, and then 1 squared. Right? After that, we have limit x approaches -1. We still have the same numerator because we not expand. Okay. And then for denominator, we can simplify third and squared here. So we get x plus 2, no more radical. And then minus 1 squared equals to 1. Okay. And then from here, we can simplify denominator. So we get x plus 2 minus 1 equals to x plus 1. We still have the same numerator. Okay. We no need to expand numerator because this is not conjugate for each other. Okay. Alright. So from here, we have same term. Okay, same factor, which is x plus 1. Okay. So, we can simplify x plus 1 in numerator and x plus 1 in denominator. Okay. We simplify this. And after we simplify, so we get limit x approaches negative 1, set x plus 2 plus 1. Right? From the previous slide, we get this. Limit x approaches negative 1, set x plus 2 plus 1. From here, we can use direct substitution. When we use direct substitution, we just replace negative 1 into variable x here. So we get set negative 1 plus 2 plus 1. Okay, we substitute here. Okay. And remember, after direct substitution, no more limit expression. Right? Then we simplify. 2 minus 1 equals to 1. Square root of 1 equals to 1. And then plus 1. Okay? And after we simplify again, we have 2. So this is the final answer. Okay? After we solve this limit, we get the final answer equals to 2 using multiplying by the conjugate. Right? Got it? Now we look at example 3, limits involving radicals. Find limit t approaches 4, half minus 1 over set t over t minus 4. Okay, we are given fraction within fraction. Okay, let's say we use direct substitution. Okay, when we use direct substitution, we just replace 4 into variable t here. So we get this. Okay. And after we use direct substitution, no more limit expression here. Okay. Now we replace 4 into variable t here. So we get square root of 4 equals to 2. Okay. So we get this. Half minus half over 4 minus 4, which is equals to 0 over 0, which is error because this is indeterminate. Okay. Means that we cannot use direct substitution to solve these limits, right? Right, to solve this problem, if there are fractions within fractions, first try to combine the fractions, right? From the given question here, we have fractions within fractions, okay? First, we can combine this denominator. So we can write this. Okay, we can write over 2 set t, and then set t times 1 equals to set t, and then in between is minus, and 2 times 1 equals to 2. So we get the first fraction. Okay, the top fraction we have set t minus 2 over 2 set t, and then over t minus 4. Okay, and from here, we can write like this. Limit t approaches 4 set t minus 2 over 2 set t times 1 over t minus 4. Now we have fraction multiplied by fraction. So we just multiply numerator and numerator, and we multiply denominator and denominator. So we get this. Okay, limit t approaches 4. Set t minus 2 times 1 equals to set t minus 2. And then 2 set t times t minus 4 equals to 2 set t in bracket t minus 4. Alright? Alright, from here to here, how we get this? Okay? From limit t approaches 4 set t minus 2 over 2 set t over t minus 4. Okay, we can write equals to limit t approaches 4 and then set t minus 2 over 2 set t per here or over here means divide by t minus 4. T minus 4 here means t minus 4 over 1. And if we have division function here, we can change to multiplication. But we need to exchange numerator and denominator. So we can write times 1 over t minus 4. Alright, from here, we just multiply fraction and this fraction. So we multiply cert t minus 2 by 1. So we get cert t minus 2. And we multiply 2 cert t and t minus 4. So we just write 2 cert t and t minus 4 we put inside bracket. So that's why we get this. Right? Right. We recall back. Conjugate is a radical expression that involves a sum or difference of the two terms. Okay, so from here, between cert t and 2 here, okay, we have minus sign. Okay, and then between cert t and bracket t minus 4 here, we have multiplication operation. Okay, alright, from here, which one? We will choose their conjugate. Okay, either from cert t minus 2 or cert t times this bracket. Okay, we recall back here, conjugate is a radical expression that involves a sum or difference. Difference means minus. So in this case, we choose the conjugate for this radical. Okay, so means that the conjugate of cert t minus 2 equals to cert t plus 2. Right? Right, from here, we multiply by the conjugate of cert t minus 2, which is cert t plus 2. Okay? We need to multiplying the top and bottom by the conjugate. Okay? Because since the top and bottom are the same, that means this fraction is equals to 1. And when we multiply by 1, it will not change the original value. Alright, that's why we need to multiplying top and bottom by the conjugate. Right? And then from here, we have fraction times fraction. So we just multiply numerator and numerator. And we multiply denominator and denominator. Alright? Alright. Now look at numerator here. Okay? We have conjugate each other. Okay? So we can simplify using a plus b times a minus b, which is equals to a squared minus b squared. Okay? But in denominator, this is not conjugate each other. So we no need to expand. We just leave like this. Right? Okay, from here, we have limit t approaches 4. So from numerator here, after we use this formula, so we can write cert t squared. Okay, because cert t equals to our a. Okay, minus and then 2 squared because 2 is our b. Right? From the previous slide, we get this. Right? Then we can simplify cert and squared here. So we get t minus 2 squared equals to 4. Okay, no more radical expression. Okay, and from here, we have same factor, t minus 4 in numerator and t minus 4 in denominator. So we can simplify. Okay. Alright, after we simplify t minus 4 in numerator and t minus 4 in denominator, so we have this. Limit t approaches 4, 1 over 2 cert t, and then times cert t plus 2. Right? Right after that, we can substitute the value of t into whatever t here. So we get this. 1 over 2 times square root of 4 times square root of 4 plus 2. Okay? And remember, after direct substitution, no more limit expression. Alright? Then we can simplify. So we get 1 over 2 square root of 4 equals to 2. And the square root of 4 here equals to 2. And then plus 2 equals to 4. And 1 over 2 times 2 times 4 equals to 1 over 16. Right? This is our final answer. Okay? We recall back. When we use direct substitution, the answer gives 0 over 0. Okay? Which is undefined. So we cannot use direct substitution for this question. But since the function is given in fraction within fraction, so we need to combine the fraction first. Okay? And after that, we can multiply by the conjugate. And after multiply by the conjugate, we can simplify the radical expression. Then we can use substitution method. Right? Got it? So we get this answer. Coming up next, evaluating limits involving radicals using multiplying by the conjugate continue. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.